copper. First procedure, you measure about 20 centimeters cube of 20 centimeters cubed of dilute sulfuric 6 acid. Hand it to the beaker. Put it to the beaker, and then you warm the acid. You warm the acid. Again, why are you warming the acid? You warm the acid to speed up the reaction between sulfuric 6 acid and copper 2 oxide. When you hand then copper 2 oxide to the sulfuric 6 acid, you stir a little at a time as you hand sulfuric sulfate solution. And then after that, the solution that is formed, you'll filter and collect the filtrate. Filter and collect the filtrate. Then transfer the filtrate on the evaporating dish or evaporating basin. On a evaporating basin, evaporate the filtrate over a water bath to a saturation. Now evaporate over water bath to a saturation point. Now this round, now you evaporate the filtrate over the water bath. Now, why are we evaporating over the water bath? Reason, you evaporate over water bath. Remember, we want now to have a copper 2 sulfate crystals which is incorporated with the water. So we need now to have the copper 2 sulfate having crystals in it incorporated with water. That is hydrated copper 2 sulfates. Hydrated copper 2 sulfates. Now, after you have evaporated, you allow the crystals to form. When the crystals form, you allow them. You dry the crystals between the filter paper. You dry the crystals between the filter paper. Now, that is a procedure on preparing copper 2 sulfate. A procedure on preparing copper 2 sulfate. Now, let's go through two. So we point out why we are doing this, why we are doing the copper 2 oxide in excess, why are we warming there? That is go to discussion on preparation of copper 2 sulfates. Now next discussion, that is the reaction between copper 2 and dilute sulfuric 6 acid. As you can look on the screen, the copper 2 oxide, when it reacts with sulfuric 6 acid, will produce copper 2 sulfates plus water. That is that chemical equation on the screen. And the type of reaction between copper 2 oxide and sulfuric 6 acid, that type of reaction referred to as neutralization. Another point to note about when preparing copper 2 oxide, this copper 2 oxide was hardened or was hardened to the dilute sulfuric 6 acid. That one, the excess copper 2 oxide is used to ensure that all the acid, that is copper 2 sulfate, to ensure that all the acid react with acid, to ensure that all the acid has reacted. And remember the reactions between the acid and the oxide, it is a little bit slow. Also, we warm the acid, that is to speed up the rate of reaction. The rate of reaction, that is the reaction between acid and oxide. And oxide, for instance, copper 2 oxide, the reaction is a little bit slow, but to speed up it, we warm the acid before you add copper 2 sulfate. Another point to note, you have noted in procedure, evaporation of the filtrate. Evaporation of the filtrate are done over the water bath. Over the water bath, and evaporation is normally done slow by slow. That one, it is for formation of large crystals. Formation of large crystals. And also the evaporation is normally done slowly for formation of large crystals, and also the crystals left for some time. It is not left for some time, not evaporated directly. That one to ensure that the copper 2 sulfate having the water in it. That copper 2 sulfate is found as hydrated copper 2 sulfate. Hydrated copper 2 sulfate. Hydrated copper 2 sulfate. Now that is the method of preparing a soluble salt. That is the reaction of a soluble. The reaction of oxide, that is insoluble base with an acid. Other salt that can be prepared by the same method. We have on the screen, you can refer these salts. We have lead 2 nitrate and magnesium sulfates, calcium chloride. Those are some of the examples of salt that can be prepared by reacting insoluble base with an acid. Again, let us now look at the equation that will be formed when, for example, when preparing lead 2 nitrate using an insoluble base. Using an insoluble base. For example, the salt that can be prepared by the lead 2 nitrate. Lead 2 nitrate. I write for you one chemical equation for the reaction that involves between lead and dilute lead oxide and a dilute nitric acid. For instance, insoluble base, we have lead oxide solid plus dilute nitric acid. Dilute nitric acid. Now learners, what is be formed when lead oxide, which is insoluble base, and dilute nitric acid will produce lead nitrate. Again, you follow the rules of balancing the chemical equation. You write a correct chemical formula of lead nitrate, or lead 2 nitrate. That is, the lead 2 nitrate is a soluble salt plus water will be formed. That is liquid formed. Now, you ensure you confirm whether the chemical equation is balanced. You balance where the atom, you balance the compound that is having the atom that is not balanced. In our case here, nitric acid, the atoms, they are not balanced. You put 2, use the lowest multiple to balance the chemical equation. Now you balance the chemical equation like that. Now, the other method, the other salt that can be prepared by the same, you can write the chemical equation for the reaction between magnesium sulfates and calcium chloride. Now, these are 2 methods that are used in preparation of a soluble salt. So, the other method that can be prepared by the same method, we have neutralization. That is the reaction between a soluble base, and an acid. That is neutralization. Now on the screen you can see the third method of preparing a soluble salt by action of reacting a base, that is a soluble base, with an acid. For example, preparation of sodium chloride. It is a soluble salt, sodium chloride. You measure about, go through the procedure. Again, that will do the practical next lesson. You go there, let us go through the procedure. First, measure about, dilute hydrochloric acid and pour it in another 25 centimeter cubed of sodium hydroxide. Again, you pour it into another beaker. Here you need now to detect, to confirm the solution, whether it is acid or base. So you hand 2 to 3 drops of phenolphthalein indicator into sodium hydroxide, into the sodium hydroxide. Again, why are you adding this phenolphthalein indicator? To confirm the head point when the acid and dilute, when acid and the sodium hydroxide react. Now, when you put 2 to 3 drops of phenolphthalein indicator into the sodium hydroxide, you hand dilute hydrochloric acid little at a time. Little at a time until the color of the color pink just disappear. That is the pink. When you hand phenolphthalein indicator in the base, it will turn pink. Now, when you hand dilute hydrochloric acid here, when the reaction attain between acid and base, that pink color will disappear. Now, hydrochloric acid to the sodium hydroxide, you use the universal indicator. You use the universal indicator to confirm the resulting solution, whether it is a base or acid or a neutral. You use the universal indicator. Now, when you use the universal indicator, the resulting solutions will have a pH of 7, meaning that the resulting solution formed, it is a neutral. It is a neutral. Now, a neutral solutions contain salts. A neutral solution contain salt and the water, and the reactions which are salt and the water formed referred to as a neutralization reaction. Neutralization reaction. Again, on the screen there is a chemical equation for the reaction between hydroxide and dilute hydrochloric acid, and dilute hydrochloric acid, and dilute hydrochloric acid. Other method that can be prepared by the same method, that is neutralization reaction between a soluble base and an acid. We have potassium nitrate. We have potassium nitrate that can be prepared by the same method. We have ammonium chloride. On the screen, these examples of salt that can be prepared by this method. We have potassium nitrate, ammonium chloride, ammonium sulfates, and sodium sulfates. Again, we look at we write a chemical equation for the reaction between one of the salt that is prepared by neutralization. For example, potassium nitrate. Potassium nitrate. We can write this chemical equation when potassium, a soluble base here, it will be potassium oxide, will be a potassium oxide, and the dilute nitric acid, potassium oxide. Again, this potassium hydroxide is aqueous. We look at potassium hydroxide with dilute nitric acid, aqueous, will form potassium nitrate, and the water, which is a liquid, and the water. Now, potassium hydroxide dilute nitric acid, that is the product, sodium potassium nitrate to be formed. The potassium nitrate, it is a soluble base. It is a soluble base. Now, learners, we have learned three methods of preparing a soluble salt. We have learned through three methods of preparing soluble salt. Now, we can now review of what we learned. The first method we'll have learned, there is a reaction between a metal and an acid. Metal and an acid. The second method that we have learned, it is the reaction of an oxide with an acid. Reaction of an oxide, which is insoluble base, with an acid. And the other one, it is a reaction between a soluble base with an acid. Now, these are three methods that we have learned. Now, we can stop there. Next class we'll look at about the practical bit of it. We'll go through the practical. Thank you for listening us. Let us see you in the next lesson.